Who here remembers when the world was supposed to end in 2012? Yeah, weird times. I definitely do. Me being a gullible 8-year-old kid in 2012, not a good combination. You could have told me that this thing was going to come out of the sky and destroy our planet, and I would have believed you, and it would have kept me up for nights. Now, fortunately, no big angry video game moons are coming at us anytime soon, but the idea of a real asteroid coming to hit our planet at some point in the future, not so far-fetched. But fortunately, there's something we might be able to do about it. Today, I'm going to talk about the Double Asteroid Redirection Test, or DART, which was the first major test in getting our planet ready for defense against asteroids. I got some good news and I got some bad news. The good news, according to an October 12, 2022 Time magazine interview, Nancy Chabot, DART's coordination lead, said that nearly all of the asteroids large enough to cause planetary destruction have already been discovered, and they don't pose any threat to us. Bad news is that less than half of the smaller asteroids, still large enough to cause major regional destruction, have been discovered. So in the event that one of those comes at us, and we're not ready for it, we're screwed. But that's where DART comes in. So today, I'm going to talk about what DART was, how it worked, and what we learned from it, and what it means for the future of defending our planet. And hopefully, with what we've come to learn from DART, we might not be so helpless after all. So first, let's talk about what it was. According to NASA's 2022 page about the mission, it was the first major test between themselves, and it was a collaboration between themselves and Johns Hopkins Applied Physics Laboratory, and it was the first major test of their kinetic impactor technology. What that basically means is taking a spacecraft and slamming it into an asteroid at a really high speed, so that in the event that it's getting a little too close for comfort to us in its orbit around the sun, they can hopefully nudge it out of the way just a little bit. The spacecraft was launched on a SpaceX Falcon 9 rocket on November 23, 2021, and it hit its target on September 26, 2022. Now let's talk about how it worked. We'll go through the target asteroid that NASA chose, as well as the technology behind the spacecraft. This is Dimorphos, and it's the asteroid that NASA chose as its target for the DART mission. Gareth Collins, professor of planetary science at Imperial College London, in a 2022 interview with Space.com, said it's about 160 meters in diameter. So it's not in that range that it could cause planetary destruction, but if it were to hit the Earth, it would be big enough to destroy the entire London area. Now, fortunately, it's nowhere near close enough to us that it poses any real threat. Now, I know what you must be thinking. That looks so lonely. Look at it, it's just sitting in there, it has no friends. Man, life sucks. But fortunately, it does have a friend. You can see in the bottom left another much larger asteroid called Didymus. And according to Johns Hopkins Applied Physics Laboratory's page on the mission, Dimorphos and Didymus are what's called a binary system, which means that Dimorphos acts like a moon to Didymus and orbits around it. And the reason this is important is because it allows NASA to tell how much they actually moved Dimorphos, because they can measure the change in time that it took for it to orbit around Didymus after the impact. It's also helpful that the system is close enough to Earth that it can be viewed with telescopes. All right, now let's talk about the spacecraft. The Planetary Society, a nonprofit dedicated to furthering space research and exploration, said that the main spacecraft is a pretty tiny cube, about a meter on each side, and it's powered by roll-out solar arrays that you can see jutting out the sides there. Now, a meter by a meter cube compared to Dimorphos' 160 meter diameter, that's nothing. But according to Johns Hopkins, when the spacecraft hit Dimorphos, it was going nearly 15,000 miles per hour. That's 19 times the speed of sound. It was also operated completely autonomously by a system called SmartNav, and it was equipped with a camera so that NASA could view the impact from home. And here's a picture that was taken just 2 seconds before the impact. Now there's a pretty glaring problem here. The camera got blown to bits at 15,000 miles per hour. How is NASA supposed to see the aftermath? Well, according to the aforementioned Johns Hopkins page, the solution to that was another tiny cube that was inside the first tiny cube called Lichia Cube, which was a secondary satellite camera that's separated from the main spacecraft just before impact so that NASA could view the aftermath. You can see in the top right the massive amounts of debris coming off of Dimorphos afterwards. So what do we learn from this? What does it mean for the future of defending our planet? Well, fortunately, the mission was a huge success. According to the aforementioned Time article, NASA would have been happy if they reduced the orbital dimorphos by 73 seconds. Okay, that's pretty good. Well, they reduced it by a whopping 32 minutes. That's absolutely insane. So now we know this is a viable option. It's something that we could actually do in the event that an asteroid is on a collision course with our planet. And according to NASA's March 2015 page about the concept of kinetic impaction, while it may not be able to be used against the largest, most dangerous of asteroids, which we already know don't pose any threat to us, it may one day still be able to be used on asteroids even larger and more dangerous than Dimorphos. So, today we talked about what DART was, how it worked, and what we learned from it and what it means for the future of planetary defense. So let's take a second to appreciate how awesome it is that us tiny little insignificant humans actually moved a massive object in space. Isn't that cool? Yeah. So, hopefully, with what we've come to learn from DART, future generations of gullible, internet-using 8-year-old kids will be able to sleep at night knowing that they'll never have to face a real life 2012.